Can a $1,400 mini PC run a Frontier class 27 billion parameter model for real work? Not a toy demo, real work. This is the complete story of one box, one model, and 1 week of measurements. Every dial on this machine got tested. Every number you will see is public. The machine, a GMKtec EVO-X2 AMD Strix Halo, a Ryzen AI Max 395 with a Radeon 86S and 96 GB of unified memory. One chip, the CPU and the GPU share the same pool of memory. That single fact shapes everything in this video. The model, Qwen 3.8 27 billion parameters, Apache 2.0, free weights, no cloud, no rental, no API bill. And it is not a toy. On one public agentic index, this dense 27B scores 51, a 1.6 trillion parameter, flagship scores 50, tiny is catching up. The engine is llama.cpp, open source. The whole stack runs on hardware you can buy tomorrow. One rule for this video, if a number is on screen, a raw log backs it up. Links are in the description. Nothing here is invented. Chapter 1 was memory. A 27B model does not fit in a small box by accident. The weights landed at 4 bits, quantization at 4 bits per weight, KXL, not a guess, a measured ladder. And the ladder caught a trap. The 3-bit quant decoded faster, but it finished real tasks 35 to 50% slower. Why? It thinks in more words. Decode speed is not task speed. That one result shaped the whole config. Next, the KV cache. We ran paired tests, 60 problems, same seed, same haystack, 4 bits against 8-bit. Accuracy came back identical, exact McNamara, P equals 1.0. Identical quality, and 4.3 gigabytes handed back. The cache dropped from 9.1 gigabytes to 4.8. On this box, that is room for the full context window. Why is the cache so cheap? Because this model is 75% not a transformer. 48 of its 64 layers keep a small running state instead. Only 16 layers do full attention. The architecture did us a favor. That was the method for every dial. Write the gate first, run the pair, fail the gate, roll back. No vibes. Gates. And a surprise from the latter, context itself was nearly free. About 2.1 gigabytes per 32,000 tokens, no measured speed cost. Chapter 2, the ceiling. This model has a native context window of 262,144 tokens. Most rigs never see it. We went for all of it. One rung at a time, 96K, 160, 192, 262. Every rung gated on real tasks with a rollback unit on the shelf. Then the odometer moment, one config line changed. Context went from 98,304 to 262,144. 2.7 times the window. Same box, same model file. Proof at the very top. Exact needle retrieval at 261,130 tokens. That is 99.6% of the window. The literal ceiling. The economics matter too. Load a 200K document once. Cold prefill, 30 minutes. Then every follow-up lands in seconds. Exact quote, 23.8, yes or no, 10.0. One-line summary, 17.5. And we are not alone on this road. A stranger ran our exact config on a 128GB Strix Halo. Vulkan lost the device about halfway into context. ROCM held a full window. Their ROCM prefill ran about twice Vulkan, community numbers, attributed, linked in the repo. And to be precise, their box has 1.33 times our memory, not double. We say the ratio right or we do not say it. Chapter 3. Speed. This is where local AI content lies to you. So here's the truth, with labels. This box has 4 speeds, regime 1. Reading, prefill, 260 to 390 tokens per second. That is the machine eating your prompt. And prefill decays, double the context position, and the rate about halves. 317 tokens per second at 6K, 168 at 35K. Plan for it. Regime 2, short answers, 20 to 26 tokens per second, quick replies, math answers. Regime 3, long, sustained writing, 12 to 13 tokens per second, real prose, hundreds of tokens, that is memory bandwidth physics on this chip. No flag fixes it. Anyone quoting a bigger chat number is quoting the wrong regime. Regime 4 is the trap, 150 to 312 tokens per second. That is an artifact speculative decoding, guessing repetitive text, counting tests, loops, echoes, never real work. We label it artifact every single time. Cold versus warm is just as big. A cold 16,000 token prompt takes 41 seconds to the first token. The same prompt, warm, a quarter of a second, 160 times faster. Keep your prefixes byte stable and the cache does the rest. The honest translation, a 200-word answer lands in about 15 seconds. A 700-word answer about a minute. That is the machine you're buying. Chapter 4, Quality. Does it actually solve problems? Grade school math, the classic 98%. With conditions, always. 150 problems, temperature 0, chat lane, and a warning from our own record. An earlier raw lane read said 30%, that number is dead. The extraction was broken, not the model. We killed it in public. Code, a stratified 30-problem subset of LiveCodeBench. 20 of 30, 67%. Easy, 10 of 10. Medium, 8 of 10. Hard, 2 of 10. That 67 carries an interval, 49 to 81, at 95% confidence. Small sample, we print the interval every time. Human eval, 28 of 30, 93%. Now, the thinking question, Qwen can reason before it answers. Does capping that reasoning cost accuracy? 50 paired omni-math problems. 3 budgets, no cap. 1024, 512. Accuracy went nowhere. 44%, 40-40 again. Exact McNamara on the pairs, P equals 0.73. The gaps are noise. But the uncapped run drowned. It hit the output cap on 26 of 50 problems, still mid-thought. Median wall time, 367 seconds uncapped, 49 seconds with a 512 cap. So caps are free, and thinking pays exactly where tasks are hard. Medium band, 31% to 71. Hard band, 10 to 38. Easy band, nothing gained. Route by difficulty, that is the whole finding. Now slow down. This next part matters more than any benchmark in this video. We got something wrong, in public. Deep context tests came back strange. Exact retrieval at 25% depth. Canned off-topic answers at 35 and 75. Okay? And stop at 10 and 50. Not a fade, a snap. We published it, a map of a degenerate basin. The claim said deep context on this box falls off a cliff. Then vision broke too, 0 of 6 on real screenshots. 2 different systems, same week. That collision was the clue. 2 failures, 1 binary. We bisected every change, 1 upstream commit, C7D8722, a host buffer bug, silently corrupting compute on integrated GPUs. Read that again. It was not the model. Our instrument was lying to us. We fixed it locally, reported it upstream, and validated the upstream fix on this exact silicon. 9 of 9 paired answers. After the fix, 6 of 6 exact at 198K. Then a second seed, 6 of 6, again, all depths. Clean stops, the basin never existed. The correction is on the record. Same URL, inverted claim. We published, we caught it, we fixed it. We told you, the bug wrote our story. The fix wrote it straight. Chapter 5. What ships? The frozen config, dial by dial. Weights, quantization at 4 bits per weight, KXL, KV cache, 4 bits, both K and V context. The full 262,144. Speculation, draft MTP plus ngram, capped at 12:15.1 seconds per 200-word answer. Fastest of 4 arms measured in pairs. Thinking off by default on for hard problems. That is a routing rule, not a preference. Vision works 6 of 6 on real browser screenshots. The rig stays on this config, frozen, the book is closed. Everything is public. The blog post in English and Spanish, the GitHub repo with every raw log, every runner, every seed. The paired thinking data is 150 rows of JSON. Go check our math. That is the whole point of publishing it. If a $1,400 box can hold a model like this honestly, the question is not whether, it is what you would run on it. Subscribe if you would rather have measured than loud. Links below. See you in the next arc.